Hello everyone. My name is Karan Chauhan and my roll number is IT2K2325. Today in this video we will be discussing data science assignment questions. So now let's get started. Here's a question. Describe the concept of hypothesis in space in machine learning. Explain the algorithm find S. Find a hypothesis by find S for the following instance in training set. So we are given a table and a data set, and we have to find the S and find the hypothesis by finding the S of the following instance in a target set. So now let's get started. First, the concept of hypothesis space. In machine learning, hypothesis space H is the set of all possible hypotheses that a learning algorithm can choose from. The goal of learning is to find the best hypothesis from this space and fit the training data. Example, if an instance has five attributes and each attribute can be any value or a question mark, then the hypothesis contain all the combinations of these values. Second, find S algorithm. Find S algorithm is a supervised learning algorithm used for learning a conjunctive hypothesis from positive examples only. The steps are: first, initialize hypothesis H to the most specific hypothesis, that is H is equals to a set of 5. For each positive training example, compare with H. If attribute value differ, generalize H by replacing with a question mark. Third step, ignore all negative examples. Final step, final H is equals to most specific hypothesis that fit all positive examples. Now we will be applying the S on the given set. So now let's apply. This is the given set in the question. So step by step, let's apply and find S. Initial hypothesis of the set is given as phi set. First positive example, Japan Honda Blue 1980 economy. H is equals to Japan Honda Blue 1980 economy. So now the second positive example would be Japan Toyota Blue 1990 economy. Okay, now we will be comparing the H with our table. So after comparing, we found that the two new values of H has been added. That is, there is two question marks in the place of Toyota and 1999. Then again comparing with the third positive example, we get the final hypothesis that we got after comparing again with the with our table is Japan, question mark, question mark, question mark, economy. The next question we have is here. Explain the purpose of training test validation sets in machine learning. What is cross validation and how does it differ from a simple training validation test split? So now let's go into this. Purpose of training validation and test sets. Training set. Used to train a model. The model learns patterns and relationship from this data. Validation set. Used to tune hypermeters and select the best model during the training. Test set. Used after the model is completely trained. It gives an unbiased evaluation of how well the final model performs on unseen data. What is cross validation? Cross validation is a technique where the dataset is divided into k parts, folds. The model is trained on k minus 1 folds and tested on the remaining folds. This process is replaced k times and the average performance is taken. It provides a more reliable performance estimate. Difference between train validations, test split and cross validation. So now let's get into this. Train validation, test split and cross validation. Data is split once, data is split k times. Performance may vary depending on the split. More reliable since every part of data is used. Faster because model train only once, slower because model trains k times. Suitable for large datasets, suitable for small datasets. Now the next question. Discuss the importance of dimensionality reduction in machine learning. Compare and contrast the feature extraction and feature selection as two approaches to dimensionality reduction and provide examples of technique used for each approach. The first important dimensionality reduction. It reduces the number of input features. It removes noise and irrelevant data. It makes models faster and easier to train. It helps avoid overfitting. It improves visualization when data has many features. Second, feature extraction. It creates new features from the original ones. The new features are combinations and transformations of the old features. Example techniques: PCA, LDA, autoencoders. Third, feature selection. It selects the most important features from the original set. No new features are created, only useful ones are kept. Example techniques are filter method like chi-square and correlation, wrapper methods like forward selection and RFE, embedded methods like lasso. Difference: feature extraction changes the feature into new form. So now here's our next question. Define overfitting and underfitting in the context of machine learning models. Describe how this issue can be identified and list strategies to prevent and mitigate them. First, overfitting. The model learns the training data too well, including noise. It performs very well on the training data but poorly on the test data. How to identify high training accuracy but low test accuracy. Ways to prevent it. Use more training data. Use regularization like L1 and L2. Use simpler models. Use dropout in neural networks. Use cross validations. Underfitting. The model is too simple and it fails to learn patterns. It performs poorly on both training set and the data set. How to identify low training accuracy and low test accuracy. Ways to prevent: use a more complex model, train for more epochs, add more useful features, reduce regularization. Now on to the next question. Differentiate logistic regression and linear regression on the basis of hypothesis, parameters and cost function. How gradient descent algorithm is used to optimize the parameter. So first, here is the difference between logistic and linear regression. Here we have linear regression and logistic regression, and the basis on which we will be differentiating them. First, hypothesis function. H naught x is equals to theta to the power t x produces continuous output. H naught x is equals to 1 upon 1 plus e to the power theta x z. Sigmoid function output between 0 and 1. Type of problem used for regression problems. Used for classification problems. Output real numbers. Output probability of belonging to a class. Parameters weights theta 0, theta 1 to up to theta n. Same weights but interpreted as affecting probability. Cost function mean square error MSE. Log loss cross entropy. Decision boundary a straight line. A curve determined by sigmoid and threshold. Range of hypothesis minus infinity to positive infinity 0, 1. How gradient descent optimize the parameters. Gradient descent updates parameter theta to minimize the cost function. Theta is equals to theta minus alpha into delta j theta divided by delta theta, where alpha is equals to learning rate and this is the slope. So basically this is the slope indicating the direction of improvement. The algorithm repeats steps until the cost becomes minimum. So in our next question, we have to write a program in Python to implement logistic regression and linear regression for every method, compute and display implemented models, evaluation measures, which is applicable, such as accuracy and other value of different evaluation metrics such as confusion matrix, accuracy, precision, recall, F1 score, specificity, and loss function, RMSE and R2 score. So basically we have to apply an Python code to implement logistic and linear regression. So here's the Python code we have used by using multiple libraries and importing the NumPy. As you can see here, this is a part of our linear regression, and um, we have used many Python libraries to apply the linear regression. This is the linear regression part. Here, as you can see, as it is mentioned, there is a logistic regression part. Okay, and we are printing all this. So the output we will be getting from this Python program is logistic regression RMSE R2 score, logistic regression confusion matrix, accuracy, precision, recall, F1 score, and specificity. So on to the next, we have next question. Write one hot encoding for the given data. We have been given a data and we have to write an one hot encoding. So now let's start. One hot encoding. One hot encoding converts categorical values like apple, mango, orange into binary columns 0/1, one column for each category. Each row has one in the column representing its category and zero elsewhere. So for the fruit column, apple 1, 0, 0. For mango 0, 1, 0. For orange it is 0, 0, 1. As you can see here, we have made a tabular form including the price and the value of fruit. So this was all for the assignment video. I hope you like it, and thank you for watching the video till the end. Thank you very much.